All right, continuing our notes from yesterday, Unit 9, Topic 3, the models. Today we're going to do the interest rate models. So in the notes, we're on page 18. And this one gives you interest rate for savings. If you deposit money in a bank, how much interest does it grow each year? So there are different amounts, or there are different equations for interest rates. This is the one that we use, but depending on the banks, they have different formulas as well. All right, so labeling this stuff. It says at the top, consider an initial principal, P. So P is the principal amount, which is your initial amount. So that's how much you start with. And then it says, is deposited into account that pays an annual rate of R expressed as a decimal. So R here is your rate, your percentage, but you need to change it to a decimal. Compounded n times each year. So n here and here is the number of times it's compounded in a year. Number of times compounded. So this is the frequency, is basically what it's asking. How often is it being compounded? How often does it take your money, multiply it by the interest rate, and add it to your savings in a year? So does it happen once a year? That would be annually. Every month? That would be monthly, would be 12 times a year. So it depends what the frequency is, what these two n values are going to be. And then T is your time in years. The A value, that's your final number. That's what you end up having in your bank account at the end of the year. All right, so example 8, you deposit $2,900 in a bank account that pays 3.5% annual interest. Find the balance after 5 years if the interest is compounded annually first and then monthly second. Now, these interest rates, they're pretty high. Usually they're 1% or less. But we want to see a growth, so we're making them a little exaggerated. All right, so how much do you start with? The principal amount is the $2,900. So that's what you're going to plug in for P. The rate is 3.5. So if I move the decimal back twice, multiply it by 100, it's 0.035, not 0.35. That's only moving it back once. Make sure you move it back twice. And it says find the balance after 5 years. So time is 5. The only thing that we're going to have differently here is the N. So for annually, how many times a year is annually? That's 1 time a year. So we're plugging in 1 for N for annually. And monthly would be how many times a year? How many months are there in a year? Would be 12. So writing the formula out, and then we'll plug it all in the calculator. So P is 2,900 times 1 plus R over N would be 0.035. 0.035 over N is 1, which we really don't even need to write because anything divided by 1 is itself. And in the exponent, we're going to multiply the number and the time. So the number is 1, and we're going to multiply by the time that it wants, which is 5. So from here, I'm just going to type all of this in the calculator and get my final balance after 1 year. So grab your calculator, and I'm going to do 2,900 times 1 plus, technically you should put parentheses around this fraction, but order of operations is going to make it do that part first, so we really don't need the parentheses here, divided by 1 to the 5 times 1 is just 5 in the exponent. And we press enter. And we're talking about money here, so we round to the nearest cent. So we have how much in our bank account? We have $3,444.29. So I wouldn't do this individually because sometimes this is a very ugly decimal. Or, I'll show it with Part B. Part B, you're going to see why you don't want to do it individually as a step. You just want to type all of it in at the same time. All right, so for Part B, everything's the same except the N is going to be 12. So 2,900 times 1 plus R is still 0.035. But this time we're going to divide it by 12. And the exponent's going to be raised to the 12th. And I multiply it by 5. All right, so if I type in everything first to begin with, 2,900 times 1.035, 035, divided by 12 to the 12 times 5 exponent gives us, now you would think it would give you a lot more because it's compounded so often, but because you're dividing and raising it to the power of 12, it's actually not much different. It is different. It's more, but not by like thousands of dollars. So we get $3,453.73. So the reason I say it's better to type it in all in at once, you would do the parenthesis part first if you're doing order of operations. So 1 plus 0.035 divided by 12. You get a number that if you were to round it, it would round to 1. And that number, if it's 1, it's not going to change. It would be the 2,900 always. So you can take that, and then yes, you can raise it to the 12 times 5. And then you can take that and multiply it by the 2,900 if you prefer to do it that way. But it is important that you do not round the base, because the base rounded is going to round to 1 usually, and that's not going to make our answer different. All right, so doing the bottom part. So I'll do this one, and I'll have y'all do example 10 on the next page. So looking at number 9. Says you deposit $4,000 into account that pays 2.92% annual interest. Find the balance after 5 years if it's compounded quarterly and then daily. So again, the initial amount is the $4,000. The R value is this. As a decimal, we would move it back twice, 0.0292. And the time it wants is 5 years. So quarterly, how many quarters are there in a year? There are 4 quarters. Now I know that's every 3 months, but in a year, how many times does it happen? It happens 4 times. So quarterly is 4. Daily, we'll say in a regular year, is 365. It will not make a difference if it was 366. A little difference, but not enough to change the amount that we're going to get. All right. We do A equals P is 4,000 times 1 plus R is 0.092, or sorry, 0.292. 292 divided by N is 4, and then we raise it to the exponent. Multiplying N and T is 4 and 5. And we type it in the calculator. And go ahead and type it in the calculator. And here we'll get $4,626.33. Make the equation for B, set it up, plug it in, and tell me what the value is.